Hello everyone, welcome to this Houdini Pill. I'm Javier Toledo from Brush VFX, and we're gonna learn how to create a custom solver that will make spheres grow until they collide with each other. So let's head to Photoshop and see what we're gonna do. Okay, we are gonna create a volume, and we're gonna add points frame by frame inside this volume. These points these spheres will start with a radius of 0, and they will start growing frame by frame. Okay, so as they appear, they will grow and grow. So we need two attributes in here. One is going to be the P scale, and when the point is created, the P scale is going to be 0, and then the growing state. So growing can be either 1, that means it's growing, or 0, meaning not growing. So when they start, they should be growing. Okay, so let's jump to Houdini and start. Okay, so let's down a geometry node, and we're gonna create, for example, a cube. Okay, here's our tube, and let's convert it to a volume. Okay, so we have a fog volume here, and let's scatter one point inside the volume. So we have our point here, so as the seed changes, we get different locations for the point. So let's type $F in here, so we get different position every frame. Okay, and now let's initialize the attributes. So we need a point wrangle for this, and let's see, it's a float called P scale, and it's gonna be 0, and then an integer called growing, and it's gonna be 1. Okay, so we have our attributes here. So let's continue with this, and let's lay down a solver, and that's where all the calculations are gonna take place. So here we have the previous frame information and the input one information, being this one here. So we need to add what was in the previous frame plus what comes this new frame, so it accumulates over time, and we don't get a jumping point here and there. Okay, so let's merge these two and see what we get. As we add, we get more and more points, just as expected. But there's a small issue here. You can see here we have only 1 point, but here we have 2 points in the first frame. And let's see why this is happening. We are merging the previous frame with the current frame, but since this is the first one, we don't have a previous frame, so it's duplicating the points. So we need to deactivate this one for the first frame, and we're going to do that with a switch and a null. Very easy. Okay, so what we are going to do here is, if the frame number equals 1, activate the null, so no points are coming from this branch. And when frame is not 1, it will activate the next one. So let's see what happens now. Okay, as you can see, now we have 1 point on the first frame, 2, 3, 4, 5. Okay, this is working. So let's continue with this. Now we need to make the points grow, and this is executed frame after frame. So if we lay down a point wrangle here, and we let's say make the points grow, we need to check if the points are in the growing state. So let's see, if growing equals 1, make the points grow, and that means increment p-scale by some amount. So let's say p-scale plus equals a small amount, for example 0.002, for example. Okay, so now let's copy some spheres into these points. And press play. Okay, we have growing points as expected. Cool. Okay, so now that we have our growing points, we need to make them stop when they collide with each other, so they don't interpenetrate as it's happening everywhere right now. Okay, so let's see how we can handle that. Okay, let's say that we have points. Okay, sorry, let's clear this. Okay, we have a point here, a point here, and a point here, and a point here, and they are growing. Okay, okay, we need to look from every single of these points, point 0, 1, 2, and 3. We need to check for the surrounding points and see if there's intersection. And we can do this in several ways. We are going to use the PCFind radius function, because let's see if you can read that. PCFind radius. Okay. And what this function allows us to do is to check from every single point in a certain distance, and we're going to check this radius here for other points, but this radius thing means that it's going to take into account the other points' radius. So if this one has some radius and this one has some radius, it's going to look for this and it's going to check this and it's going to find this point. Okay? But it's not going to find this one. This, yeah? Okay. So let's jump into Houdini and see what we're going to do here. Okay, so we need to check for collisions before we make them grow, so they don't grow and then check and stop. We need to check, and if they are colliding, we're gonna make them not growing, so this won't be executed. Okay, so let's type before here, check intersection. Okay, so let's see what PCFind radius gives us. Okay, as you can see here, there's a few arguments here, and the most important thing is that it's gonna give us an array. So let's see what this is gonna give us. Since we are gonna be looking from the same points that we are gonna be looking into, this means that every point, first of all, is gonna find itself. So for point 0, the array is gonna be 0, and in this case 1. For number 3 is gonna be number 3 and number 2. And imagine that we have here point number 5, for example. This is only gonna give us number 5. So this gives us a nice clue of how we can check if there's a collision or there isn't. And this is if the array is less than 2, or well, if it's bigger than 1, the length of the array, there's gonna be a collision. Okay, so let's jump into Houdini and do exactly that. So we're gonna declare here a variable, and we're gonna call it points, and it's gonna be an array, and it's gonna be, okay, where are we gonna be looking in the first input? From where are we gonna be looking? From the position. With what radius? Okay, so p-scale. Now we need to add a radius scale, and that's gonna expand or contract that p-scale attribute. Since we want it to be exact, let's say multiplied by 1. Now where are we gonna be looking into? Position. And what's gonna be the radius of those points? P-scale. And how many points maximum we need to check? Well, we only need to find 1 point plus ourselves, so it's gonna be 2 points. Okay, so we have this. Okay, so now let's add that condition to check if there's more than 1 point in the array. So let's say if the length of the points array is bigger than 1, make them not growing. Okay, so let's see how this works right now. Looks like it's working. We have growing points everywhere, and they stop when they hit each other. Nice. As you can see, it's a perfect collision, as you can see in these 2 points, because we make them stop before we grow another step. So this is working just fine. So there's another issue here that we need to address before wrapping this up, and it's gonna be that if we keep adding more and more points here, okay, we keep adding points, more points, more points, as we have more and more spheres, some of the points will appear inside of the spheres we have, and they will immediately be discarded as not growing because they are inside of the sphere. So we'll have infinitely small spheres that won't even be visible, but it's gonna take some space and it's gonna make things slow. So let's see how we can check for that. Okay, so let's jump into the solver. These are the points that we are adding frame after frame. So let's see. We can add a point, add a point wrangle here, and we are gonna look not in itself as we did here, we're gonna look in the points that were already in the system. So let's copy this one. Okay. So now, since we are looking from a new point, a only point, into other points, all the points around him, we need to check. Well, it won't find any points because it won't find itself as happened before, because now we are not looking into ourselves, we are looking in the second input. So the array will be empty unless we find a point. And when we find a point, the length of the array will be 1. So we need to check if the array is bigger than 1. Well, sorry, if it's bigger than 0, and if that happens, that means that we spawned a point inside another sphere. So let's come back here and see. Okay, if length of the points array is bigger than 0, let's remove that point. And we are looking in the second input right now. So let's see if this is working. How we're gonna check if this is working? Okay, let's bypass this. Come up here, go to the last frame and see. We have 240 points, okay? So now let's enable this one, jump back and press play, and we have 196. Okay, so there were quite a few points that were created inside of another sphere. So we optimized our system with this. So this is it. We have the complete system working now. It's pretty fast and is working perfectly. More things that you could do here is to check, for example, collisions with the walls, so they don't grow if they have collided here, and you could easily do that checking the distance from the point to the wall, for example with the xyz dist function, and if the distance is bigger, well, if it's less than the p-scale, it's gonna be a collision, so you could deactivate the growing, and that's all. Okay, I hope you enjoyed this one. More will be coming soon. Bye bye. Thank you.